Today, we're going to cover the very first LeetCode question, toSum. In this question, you are given an array of integers, nums, and a target value. And we need to return the indices of two numbers such that their summation equals to target. As you can see in the problem description, you can assume that there's exactly one solution and you cannot use the same element twice. All right, let's take a look at the constraints. We have up to 10 to the 4 elements in the array, and all the elements, including the target value, are in the range of 10 to the 9. At the end, you can see there's a follow-up. The problem asks us to come up with an algorithm that runs better than n squared. We are going to explore all different solutions. Some of them are running at n squared, some of them will be running better than n squared. Cool. Now let's take a look at the solution. The very first solution that comes to my mind is a brute force solution, in which I will try to enumerate all the possible pairs and see if I can find a pair such that the summation of the values happen to be the target value. Specifically, what I want to do is to enumerate I from 0 to n minus 1. I'll basically do the same thing for j for 0 to n minus 1. And then I will check if nums I plus nums j equals to the target value. Remember that the n here, I can put it here that n is basically the length of the nums. If this condition happens, I would like to return the pair I and j directly. It seems that it finishes its work, right? But before we submit the answer, we need to pay extra attention that there's a requirement in the problem saying that I and j cannot be the same because you cannot use the same element twice. To prevent from that bug, we actually need to put if I equals to j, we should do a continue. With this, I believe this answer should work. But let's first analyze its time complexity. Since we have two for loops here, and we are literally enumerating all the possible pairs, the time complexity is pretty straightforward. It's n to the square. But this is actually different from what we promised earlier. We said we want to enumerate all the possible pairs. This is actually doubling the work. Why is that? Because, for example, a pair 2 and 4 and 2, they are the same thing. We should try to save some duplicate efforts here. This is actually a pretty easy fix. Instead of enumerating j from 0 to n minus 1, we can just do for j equals to I plus 1 to n minus 1, right? This will allow us to enumerate all the possible pairs. And because of that, we can actually skip this condition too. Here you are. This is the brute force solution that runs in n to the square complexity. All right, so what next? Can we do better than n to the square? Yeah, one thing that is pretty obvious to me is this is kind of a tedious work. If I want to find the number I and j that equals to a target number, do I really need to enumerate all the possible j? Can we just look it up? What I want to do is, let's take the first given example in the problem. This is the problem. Okay. When you see the number 2, do you know what you want to find in the array? Of course, because the target is 9. You need to find 7. You don't actually need to enumerate all the possible j's. If you can have a very efficient way to find the value 7 in the array, you can just return the index of the value right away. This sounds like a HashMap to me. If I am now as 2, I will try to find the corresponding value, which is 9 minus 2. And if I happen to have the mapping from 9 minus 2, which is 7, to index 1, then I can return index 1. This is the improvement I can think of. And let's actually try it out. What I want to do is, I will just write a pseudocode. For example, we have a HashMap, which has the value to index, assuming that we have this HashMap. Then what I need to do is, for I from 0 to n minus 1, I will just check if target minus nums I, this value, is in HashMap. If it does, I'll just return the answer, which is I HashMap target minus nums I. Assuming that there's a case of 2, 3, 3, and the target number is 6, we need to make sure we return this pair instead of, itself twice. There's some trick we need to pay attention to when we actually implement a solution. The hash map might not just map to like a single index, it will be a list of index. And we need to make sure we don't use the same index twice. We'll cover this part in the actual coding implementation. Now, what's the complexity of this algorithm? Assuming that the hash map can run in O1, then this check is O1. This check is also O1. This is ON, so the complexity becomes ON, right? This is the final complexity. But before we move on to the coding part, there's another solution I want to talk about, which is going to be pretty helpful in different problems. If we can sort the array earlier, let's say we sort the array, let's use the same example, 2, 7, 11, 15, and the target number is 9. There's a good property of this array if we sort it earlier, because once it is sorted, the larger the value the left pointer is pointing to, the smaller the value the right pointer is pointing to. This is called a two-pointer problem. The third solution that we can also explore. So as we described earlier, there are 3 different solutions. There are brute force solution, there are a lookup solution, and then at the end there's a sorting plus 2-pointer solution, right? In the brute force solution, it's pretty straightforward. We will just enumerate the possible value of I, also the possible value of j. But remember, here I want to start with I plus 1, so that we can save like half of the complexity. All right, so once we have I and j, we'll just check if the number of I plus j equals to the target value. So I will return I and j. This is basically the first solution, and let's submit and check if it's working. You can see the complexity, since it's n-squared, you can see it's not performing too well compared to most of the candidates. Cool. Now let's dive into the second solution, which is build a lookup table first and then check each of the elements in the array and see if the counterpart is in the lookup table. And remember that we cannot just build integer to integer mapping, but instead we need to build a mapping between the value to the list of indices, because it is possible that the same value appears multiple times in the array. Specifically, I want to build index list by value. This is a dictionary. Instead of using a normal dictionary, I would like to use a default dict, so that if a new key appears, when I access the dictionary, I will directly get a list object, so I can append the new element into the list directly. So specifically, I will do for I in range n, and I'm going to access this value by nums I and do an append here. After this, we already have a lookup table. Now we just need to go through a list again and see if we can find a corresponding part of the value in the lookup table. I'm going to call it counterpart equals to target minus nums I. There are a couple of possibilities here. The first case is that the counterpart does not even exist in this dictionary. If that's the case, without doubt, we should skip. We should just find the next element and check its corresponding part. However, if it does exist, then there's a case that the value itself, counterpart, actually is the same value as the numbers. And then at the end, there's another case that they are not the same. If they are the same, it's pretty tricky, because we need to make sure there are more than one values. For example, in the case that you have 3, 3, target 6, you need to make sure you actually have 2 3s in the array. If you only have 1 3, then this is not a valid answer, right? We should first check if the counterpart has more than one value. If it does, then we find the answer. If it's only one, again, we should skip this solution. Else, let's think about like what is the possibility of the length here. Could be 0, the possibility is already eliminated. Could be 1, possibly. In this case, we'll skip it. Maybe 2, then this is the answer we want to return because we find a pair of indices. Maybe more than 3. That's not possible because otherwise we'll have more than one answer. So it is pretty safe to just return this pair directly from here. And at the end, is it possible that counterpart happens twice in the array? Not possible. Otherwise, we'll have more than one answer. It is pretty safe to return the index of I and counterpart 0. Because this is guaranteed that there's only one commit here. Now let's skip the brute force parts and actually submit it and see how much better it is compared to the first solution. Cool. Yeah, this is expected. This is running a lot faster compared to our brute force solution. And the runtime is only 65 compared to more than 2 seconds. All right, now let's dive into the final solution I want to cover here, which is a sorted first and then 2-pointer solution. Before actually starting implementation, you need to be careful that if you sort the array, you mess up the index in the original array. Before you do that, you actually need to make sure you keep that value somewhere. The way I would do it is, nums is just the array itself. I would like to enumerate it. But once you enumerate it, this is you'll return a pair of index first and number second pair. This is not exactly what I want because I want to sort by the value. A way to do it is I will make this comprehension. For index and number in this array, I would like to build number index pair. And then I would like to sort it as, I will have this, so it's sorted pairs. All right, or you want to be more specific, I would say num and index. And it's now sorted increasingly. What I will do is I'll have basically like left and right being the 2 pointers. And I'll do while left pointer is smaller than the right pointer, I'll keep doing this until I find the answer. I will basically do if the pair, so this is the index, I want to get the value. Value is the very first element of the pair. If this plus the right pointer, if the value here is the target value, then I'm good. I'm going to return the indexes. Okay, so I'm going to return a pair here. Otherwise, there will be 2 possible outcomes. One is this value will be smaller than the target, or it will be larger than the target. Okay, as I mentioned earlier, if it equals to the target, I can return the indexes directly. So what I will do is I will do this guy and this guy. Remember, this pair has 2 values. One is the number, one is the index. We are comparing the value here, and then we're returning the index here. So one is the index. This will give us the index. And okay, now let's think about this case, right? So if the summation of the values is smaller than target, I will move the left pointer to the right so that the value will be larger. And the other case will be this. It is guaranteed that one answer will be returned here. Okay, we actually need to comment out this one. And then let's check if it passes all the test cases. Okay, I make a mistake here. Okay, this is not the correct way of doing a value assignment in Python. I actually need to do this. Let's see. Okay, it passes all the test cases. Now let's do the submission. Cool. So somehow the runtime is actually even lower than the previous solution, even though this complexity should be slightly worse. But yeah, that's it. This is all 3 different solutions that we can have for this answer. And thank you for watching.